interpretation. Now at the time of SYN packet exchange, both parties can agree upon this window scaling option with the scale sizes can be decided. No, I'll not interpret it as 1048 bytes. I will interpret it as 1048 words, where each word is of 16 byte. Then your sequence number will be given to every 16 bytes. Got the point? Abhi,
Yes.
every byte is having one sequence number, okay? And then in this interpretation, every 16 bytes would be having one sequence number. Got the point?
Yes, sir.
In this way, you can increase the packing factor of the window. Okay, so if we move ahead after window scaling, the another issue is adaptive retransmission. And this is the most studied portion of TCP. Most studied, most evolved, and most difficult to understand portion of TCP. So I want everybody to be, you know, keenly listening to what I'm saying, and if there is a slightest of doubt, you can interrupt me. TCP guarantees the reliable delivery of data, as we know. They transmit each segment if acknowledgement is not received in a certain period of time. Now, as I told you that this timeout has to be set, has to be adaptive according to the network condition. The timeout is set as a function of the expected RTT between the two ends of connection. We know that choosing an appropriate timeout value is not easy because this RTT is a variable entity, variable value. Much variation is experienced between the two hosts over time. And that's why TCP uses an adaptive retransmission mechanism, which has actually evolved a lot over time. So your timeout should be set as a function of RTT, but RTT is a variable value. If you observe the RTT between two end hosts, you may find RTT value is different over a period of time. Now the problem here is, if you think here, when you will be able to get the RTT value, you send data and then you receive the ACK. And then only you'll get the RTT. And what I'm saying that when you are about to send data, you have to set the timeout value, which is a function of RTT, which is dependent upon RTT. तो RTT एक्चुअल RTT पता तो बाद में चल रहा है, बट उसको यूज करके अपन को टाइम आउट सेट करना है जब ये पैकेट भेजना है. दैट इज द मेजर थिंग. अभी ज्ञान समझ में आया?
Yes, sir.
So that's challenge. Your timeout is going to be a function of round trip time, but round trip time will only be known when you get the acknowledgement back. But you want this RTT value at the time of sending the segment, because this time the RTT value is going to be utilized to set up the timeout value or timer value. Now, how this is done in TCP, that is interesting. If we see the original algorithm, initial TCP algorithm, it was very simple. It was very simple. The original algorithm was given in RS3 0793, and this algorithm was very simple. Maintain a running average of RTT. Not just understand, and then compute the timeout as a function of this RTT. Every time TCP sends a data segment, it records the time. Okay. when the acknowledgement for that segment arrives. So TCP reads the time again. तो जब भेजेगा तब टाइम पड़ेगा, जब acknowledgement आएगा तब टाइम पड़ेगा, and take the difference of this time, and this is known as sample RTT. This is RTT sample. Now what is estimated RTT? Is a weighted average between the previous estimate and this new sample. So what you can say that suppose estimated RTT for round n plus 1 would be alpha into estimated RTT of round n and sample RTT of round n. So what you are doing when you are sending a packet, you'll be using estimated RTT. और वो मिलेगा कैसे? अल्फा इंटू जो प्रीवियस एस्टिमेट था वो प्लस 1 माइनस अल्फा इंटू इसको भेजने के समय जो एक्चुअल सैंपल मिला. तो प्रीवियस एस्टिमेट यहां पे यूज हुआ था, सैंपल यहां मिल गया. फाइन. Should I explain it clearly? See here. Suppose I'm sending nth packet. I don't have sample here. I have estimate, some estimate. When we receive the acknowledgement, I'll get the sample, nth packet, sample for nth packet. Now when I send the next packet, my estimate of n plus 1th round would be what? Alpha into estimate of nth round plus 1 minus alpha into sample of nth round. And this we keep on doing with every round because there is no other way of doing the thing. You can take the initial estimate, some constant value, and then keep on doing this. Now here comes the important point. What should be the value of alpha? Now if you see, the parameter alpha is selected to smooth the estimated RTT. A small alpha tracks changes in RTT, but it perhaps too heavily influenced by temporary fluctuation. A large alpha is more stable, but perhaps not quick enough to adapt to the real changes. See here, if I take a small alpha value, fine, a small alpha value, then this 1 minus alpha will be bigger. Means more preference will be given to the actual sample in the next estimate. If you take bigger alpha value, then less preference is given, or the sample RTT will be less dominant. Actual value will be less dominant in the next round. So that's what they have done after doing a lot of checks and doing simulations and implementations. They recommended alpha between 0.8 and 0.9. And they started calling estimated RTT as smoothed RTT. Smooth RTT means SRTT. Now, after getting the estimate RTT or SRTT, smooth RTT, TCP uses this value SRTT to compute the timeout in a rather conservative manner. See how it is conservative. See, please with me. Please be with me. RTO retransmission timeout would be minimum of upper bound, comma, maximum of lower bound, smoothed RTT into some beta. Beta is a delay variance factor with a recommended value of 1.3 to 2, and generally it is taking as 2. Upper bound is an upper bound suggested to be 60 seconds or 1 minute. 60 seconds, 1 minute. And lower bound is a lower bound. L bound is a lower bound suggested to be 1 second. So means your upper bound of RTO retransmission timeout would be 60 seconds and lower bound would be 1 second. So if you just solve this, what is the result? It generally results in RTO being set either to 1 second or about twice to smooth RTT. So if you take beta as 2, तो इन दोनों में जो बड़ा 1 सेकेंड बड़ा होगा तो RTO 1 सेकेंड ले हो जाएगा. अगर ये वैल्यू बड़ी होगी सो ट्वाइस ऑफ SRTT हो जाएगा. तो किताबों में क्या मिलेगा? RTO equal to 2 of SRTT, which is not wrong, but the actual definition is this. Now, this was the initial original algorithm given in RFC 0793. Now, this RFC RTO value is calculated using 6298 RFC. Fine. So after 0793 2988 came, and then which was oscillated by RFC 6298. So in this, TCP sender maintains two state variables, SRTT, as we have seen, and RTT variance, round trip time variation. And then there is an interesting thing which is known as clock granularity. Until a round trip measurement has been made for a segment sent between the sender and receiver, the sender should set RTO to 1 second. जब तक कि एक RTT मेजरमेंट नहीं हो जाएगा एक्चुअल, तब तक RTO 1 सेकेंड सेट रहेगा. यानी कि पहले राउंड में इनिशियलाइजेशन RTO का 1 सेकेंड होगा. मेरे साथ रहिएगा. 3 वेरिएबल इकट्ठा हो गए. SRTT जो भी पहले देखा, RTT वेरिएंस, what is the variation, clock granularity. I'm just coming to it. What do you mean by this clock granularity? And then initialization of RTO is 1 second until one actual RTT is being measured. When the first RTT measurement R is made, the host must set smooth RTT as R, RTT var as R by 2, and RTO would be by this equation. SRTT plus max of granularity, comma, K into RTT var where K equal to 4. ये पहला, जब पहला RTT मेजरमेंट हो जाएगा तो स्मूथ RTT, ऐसा RTT की वैल्यू R, RTT वेरिएंस की R by 2, and RTO would be by this equation. When a subsequent RTT measurement R dash is made, then see, we can calculate RTT var also. RTT var would be 1 minus beta into RTT var, पहले वाला. RTT var of the next round would be 1 minus beta into RTT var of this round, plus beta into SRTT minus R dash. पिछला SRTT minus R dash. And SRTT would be 1 minus alpha into SRTT plus alpha into R dash. And the above should be computed using alpha equal to 1 by 8 and beta equal to 1 by 4. After the computation, a host must update RTO by SRTT plus maximum G, comma, granularity, comma, K into RTT where K equal to 4. I know it's looking bit cryptic, but the things are simple. I'll be coming back to this. Now, this is important. Value of SRTT used in the update to RTTVR is its value before updating SRTT itself. ये इसी ऑर्डर में होगा. ये SRTT पहले वाला है, ये SRTT बाद वाला है, क्योंकि this is you can say जो भी SRTT वेरिएबल वैल्यू अभी थी उसको यूज करके RTT var निकाल लिया, फिर नेक्स्ट SRTT निकाला पुराना SRTT वेरिएबल की वैल्यू यूज करके. ये ध्यान रखने की चीज है. Updating RTT var and SRT must be computed in the above order. After the computation, this is the value. Host must update RTO equal to SRTT plus max of this where K equal to 4. Whenever RTO is computed, if it is less than 1 second, this is again a good rule at that time. Whenever RTO is computed, if it is less than 1 second, then the RTO should be rounded up to 1 second. Now, why this was done and what do we mean by this G thing, granularity? So let us come back to granularity first. Clock granularity. Can anybody explain me the clock granularity? Any idea about clock granularity? Abhigyan, Divyansh?
I don't know.
Divyansh?
Same, sir, no idea.
Okay. Have you used weighing scale some point of time?
Yes.
So मिलीग्राम में तौलता है तुमको? कहाँ तक जाता है? किलोग्राम तक जाता है, ग्राम तक जाता है?
Yes, ग्राम तक जाता है. हाँ.
So minimum weight which you can measure is 1 gram or 100 gram?
डिजिटल में 1 ग्राम.
So 2 डिजिट तक देता है वो?
सर वो 3 डिजिट वाला यूज किया था.
1 ग्राम.
यस सर.
1 ग्राम तक आपको वेट देगा वो, ठीक है? उसके नीचे अगर आधे ग्राम का सामान रखोगे तो क्या आएगा?
आई थिंक 0 आएगा क्योंकि वो करती वैसे वैल्यू लेता है.
0 आएगा ना? So similarly the clock granularity. Fine. If I say that clock granularity is 1 second, it means what? 1 second के नीचे का कुछ कैलकुलेट ही नहीं होगा. ओके? जो मेरे सिस्टम की अगर क्लॉक ग्रैनुलरिटी 1 सेकेंड है तो इवन इफ आरटीटी 5 मिली सेकेंड का आ रहा है उसको समझ में नहीं आएगा. आर यू गेटिंग माई पॉइंट और नॉट?
So basically granularity is least count.
Granularity is the unit of time it can measure. Fine. The smallest chunk of unit it can measure.
Okay, sir.
So that is having a lot of bearing in this equation. At that time when this particular RFC came into picture, G was not important. Fine. Because granularity was at that time 1 second. So if I take this equation again of 6298 RFC, starting is two variables, smoothed RTT, the way we have seen, and RTT variance, round trip time variation. Until a round trip time measurement has been made, let us take the snip. Let us describe this on the whiteboard. Suppose your data transfer is starting. You don't have any RTT. So when you send the first packet, your RTO would be taken as 1 second when you transfer the first packet of this connection. RTO would be set as 1 second. Now, when the first RTT measurement is made, so measurement will be made when you send the packet and you receive the acknowledgement. So this is first RTT measurement. First RTT. When the first RTT measurement is made, the host must set. Now you set the variables. SRTT equal to R. Suppose first RTT measurement is R. And what we have done? RTT var equal to R by 2. RTT var equal to R by 2. And now what is the equation? Equation of that is RTO equal to SRTT, which should be R plus maximum of G, any granularity you can take, comma K is 4 into RTT var, which is R by 2. Fine. So what would be the leading parameter? Leading parameter G is 1 second, so K is 4, RTT var is R by 2. You multiply it, take the maximum, and you get the RTO of this round. So in this round, when you take the things, you get the RTO value by equation. Putting these things in the equation. After setting the RTO, you send the value again, packet again, and you get the another RT, which is R dash. When you get the another RTT var you need to calculate. So RTT var, we have equation for that. 1 minus beta into RTT var. So you are calculating RTT var. Next round, fine. 1 minus beta RTT var. अभी RTT var क्या है? क्या है अभी RTT var? वेरिएबल की वैल्यू R by 2 प्लस बीटा इंटू SRTT की वैल्यू क्या है? R माइनस R डैश एंड मॉड उसका, ठीक, जो भी R डैश अभी आया, तो RTT वैर मिल जाएगा, ठीक है, इस राउंड का, ठीक, एंड SRTT वुड बी 1 माइनस अल्फा इंटू SRTT, ये क्या है वैल्यू अभी? R इंटू प्लस अल्फा इंटू R डैश, जो R डैश तुमने कैलकुलेट किया, एंड दिस keeps on going. And in this way, you'd be having the role of RTT variance also in calculation of RTO, which is more near to the actual happening. So if you see the previous original algorithm, it was not very much smooth because it was not taking the variation in RTT into account. But now variation of RTT is also taken into account to get the proper estimate. Traditionally, TCP implementations use coarse grain clocks to measure the RTT and trigger the RTO, which imposes a larger minimum value of the RTO, because at that time Linux granularity was 500 millisecond at that time. Nowadays Linux granularity is 1 millisecond. Okay, we'll stop here. We'll stop here because it is enough for today. A lot of things you have done, but I would suggest that you go through these things, fine, and see it carefully. See it carefully, and if there are any question, we can discuss on the next turn. Fine. So your test and quiz, whatever is there, would be after your lab class on Friday. Okay, because lab class is generally over in half an hour, 45 minutes. So we'll be having a full-blown quiz or whatever subjective quiz or exam on your lab class on Friday. Fine. If there are any question, you can ask. And in examination up to today's lecture, everything will come. Okay. So I will discuss the doubts of today's lecture before the examination in the lab class, and then we'll have the examination. And I'll consider this particular exam as a midterm exam, I'm telling you. Fine. So that would be taken very seriously. If you want more time, you can tell me right now. So we can shift it to Monday. Because I'll consider this particular thing as a midterm exam. So either you want to give it on Friday, it's okay. Otherwise, we can shift it to Monday also. It would be subjective quiz.
सर मंडे
मुझे पता था. ठीक है, तैयारी करो पहले. फ्राइडे को इस लेक्चर के डाउट्स पूछ लेना और फ्राइडे को थोड़ा सा और हो सकता है पढ़ा दो. ठीक है? ओके. चलो. If there are no doubts, then you can leave. Thank you. कहाँ निकल गए? क्लास हो गई मेरी? अच्छा अच्छा ठीक. खाली हो गया? क्लास थी मैम. अरे ये लड़का, इससे पूछिए ये MS टीम आईडी की बात कर रहा है कि जी सूट आईडी की बात कर रहा है. पता नहीं जी सूट क्यों लिख रहा है, वो तो हम भी नहीं समझ पा रहे हैं, लेकिन MS टीम से भी ये मेरी क्लास में भी है. ये भाई साहब अपना पहले बनाए होंगे एक. ठीक है. और हमने लाइसेंस असाइन किया होगा. ठीक. इनसे कहिए कि ये हमको फोन करें कल. ठीक. तुम्हारा नंबर दे दें इसको? हाँ, मेरा नंबर दे दीजिए और हमको फोन करें, तब इनका हम केस समझेंगे. ठीक है. ठीक है. हाँ. क्योंकि ये टिपिकल लग रहा है. नहीं तो ये तो या तो लॉगिन नहीं किया है, या तो इसने वर्क और स्कूल अकाउंट चूज नहीं किया है, जैसे हम लोग करते हैं ना. गड़बड़ी हो रही है. लेकिन हमने तो
आपने दिया, लेकिन ये लॉगिन किससे कर रहे हैं? पर्सनल अकाउंट से लॉगिन कर रहे होंगे,
लॉगिन किससे कर रहे हैं,
उससे गड़बड़ हो रहा होगा। तो जरा हाँ, ये हमसे बात करेंगे तो हम फिर बता देंगे। ठीक है, ठीक है, ओके। अभी निकले हेड्स आपके पास होंगे? अच्छा, आ रहा हूं मैं भी, क्लास अभी खत्म किया हूं। अरे राम, आज का टॉपिक बड़ा कठिन होता है, एडेप्टिव रिट्रांसमिशन। ऑनलाइन समझाना तो फायदा नहीं है कि हम डिस्टेंस लेंगे, आपने क्या देंगे ना, टेंशन में कुछ नहीं, कुछ नहीं। हाँ सर, हम भी आ रहे हैं, बोल दीजिएगा, कह दीजिएगा कि सर हम भी आ रहे हैं।